Hi everyone. So we've gone over the structure of bones. We've gone over how bones develop, and now we're going to go over what regulates, what affects the eventual length that bones can grow, or the size that bones can grow. And we're going to talk about it outside of genetics because obviously your genes, what you inherit, has an impact on how tall you can potentially grow. However, your nutrition, the elements of how your life is lived, and the physiology of your body also impact your ability to grow, and we're going to go over those things. So that's mainly going to go over diet as well as the effect of hormones in your body. Okay, so in terms of bone growth, diet plays a pretty big role because your bones are a major storage site for a lot of minerals. So what you eat ends up affecting the ability for you to store those minerals on your bones, and thus the size of your bones. So because minerals make the dominant amount of the matrix, 2/3 of your matrix, and your bone is a lot of matrix, is from calcium and phosphorus stored in the ground substances in the matrix. Then if you don't have enough of either of those minerals, then you're not going to have as much bone growth, and you're also going to have bone loss and thus weaker bones, and those weaker bones tend to compact and shrink over time. All right. By the way, for those of you wondering what's a mineral versus what a vitamin is, we're going to go over those definitions. So mineral is an inorganic element or molecule that your body needs. So it's usually like an atom or an ion that is in the periodic table. That tends to be a mineral. So phosphate is an ion, PO4 and 3-, and that's actually the source of phosphorus that your bones use. Calcium ion is what's in your calcium, Ca2+. Generally speaking, if it's a metal, a metal atom, or if it's an ion, that's what classified as a mineral. Vitamins, on the other hand, are actually really big molecules. In fact, it's kind of I would never write out the actual molecule formula because it's quite large for a vitamin. That's why we give them nicknames: vitamin A, vitamin D, vitamin K. All those represent very large molecule formulas, but instead of us writing a huge formula, we just say D, B, etc. So vitamins, on the other hand, are big organic molecules. Organic meaning molecules containing lots of chains of carbon, but it's a vitamin, not a nutrient, because you only need a very tiny amount of it in order for your body to run properly. So it's a big molecule that you only need a little bit of, but that little bit is necessary for your body to develop and grow properly. So vitamin D is a very important vitamin. Its big thing is it stimulates your calcium resorption and transport. I shouldn't say resorption. It just stimulates your body's ability to take in calcium from its diet, and thus that it will also affect how much calcium you can get onto your bones. That's why you tend to see vitamin D in milk, because vitamin D is necessary for your body to take in milk's calcium and then put it into your bones and put it into your blood. Okay? So you can make vitamin D two ways. You can either get it from diet, or you can just get sun exposure. You actually form vitamin D in your skin when you go into the sunlight. So you can eat fatty fish or drink fortified milk, or just go outside and enjoy the sun on your arms and face. Now, what happens if you don't have enough vitamin D? This was a really big deal in the industrial era in the late 1800s because unfortunately there was a lot of child labor at that point, and everyone was stuck inside factories. And of course, during the industrial era in the late 1800s, kids weren't getting a lot of food, or not nutritional food anyways. So crappy nutrition, not enough sunlight, not enough vitamin D, and what ended up happening is the kids ended up getting these soft bones that ended up curving. This is called rickets. So rickets, because of the lack of vitamin D, you're not mineralizing, you're not adding enough calcium to the structure of your bones. So remember, bones are, if you recall the structure of bones, it's a connective tissue made of a matrix and cells. And inside that matrix, you have your minerals and you have your fibers like collagen. So without vitamin D, your minerals don't work. They don't lay down. So you have the structure of the bone, the shape of the bone, but it doesn't harden, so it's bendy and soft and mushy. It's not mushy like a banana, but it's mushy in the sense that your bones should be like firm as hard as like a chopstick, and instead it's like curvy and able to misshape. Okay, if you put enough pressure on it. So that's why you end up getting bow legs. All right, we're going to go over 2 other vitamins, but we're not going to go in them as in depth. Vitamin C is a really important one. So remember, we have our 2 parts of the matrix that's making up that big amount of your bone, of the structure of your bone. So we have our fibers and we have our minerals. And in this case, if you don't have enough vitamin C, you don't form collagen. And collagen is the fiber skeleton that the fiber, I shouldn't say skeleton, but the fiber backing that your bone needs. So if you're going to build your bone, you need to lay down collagen, a collagen network that you can then stick your mineral into. Without that, your bones aren't going to develop well. Now, generally speaking, scurvy happens in areas of extreme malnutrition. There's a lot of vitamin C found in food and in fruits especially, so you don't typically find vitamin C lacking on land, but you do see scurvy occur in either areas with very poor, like famine, not enough food, and very famously, people on the ocean, pirates, in the way hundreds of years ago. And what actually happened is because they didn't have the ability on their ships to store fruit in the long run, they weren't getting a lot, and they were basically eating bread and water. They weren't getting a lot of vitamins, and as a result, they ended up breaking down their collagen. Their collagen wasn't developing. Now, collagen is found in all connective tissues. So what was happening then is their tissues everywhere in the body were starting to break down. So collagen is found in your connective tissues under your skin, in your deep skin layers, and your bones. So they would start getting bleeding and bruising everywhere. And then in particular, if it goes on long enough, their bones would start to kind of break down and they would feel sharp bone pain, and then they wouldn't, and if there was growth that they could have, it wouldn't be available, or it wouldn't be able to be done. But for adults with scurvy, they tend to feel bone pain, and if they had bone breaks, they wouldn't be able to repair it so well. All right, and then the last vitamin we're going to go over is vitamin A. So a good way to remember is like, oh yeah, my milk is usually, it says on my milk bottles, fortified with vitamin A and vitamin D. We went over vitamin D. Vitamin A is just an important vitamin for the function of your osteoclast and osteoblast. And remember, without the function of those 2 cells, the cell that helps wipe away crappy old bone and the cell that helps create new healthy bone, you're not going to get proper bone formation and proper storage of calcium onto your skeleton itself. So, as a result, without vitamin A, your bones don't end up developing the way they should. Vitamin A can be found in a lot of foods, especially fruits and vegetables. And I put liver here. So in areas like the Inuit, where fresh produce isn't as available, you actually find the diets of people in those areas to include the liver of animals, because liver is a very rich source of vitamin A. All right, the last thing we're going to go over is in terms of things that affect regular bone growth or normal bone growth is regulatory hormones. So regulatory hormones, if you recall, hormones are signaling molecules that your body in whatever organ releases into your blood, and then those regulatory molecules travel in your blood, and then they enter and bind to a different organ to change that organ's reaction. So, classic example, adrenaline is made in your kidneys, but when your kidney, or not in your kidneys, but in a gland right next to your kidney, and what happens is when they dump that adrenaline into your bloodstream, it flows and then goes into your lungs to deepen your breathing, goes into your muscles to tighten and tense up those muscles, and goes into your heart to help that heart start to beat quickly. And that's all thanks to the hormones being sent out from from the adrenaline glands by your kidneys into your bloodstream, and then allowing it to flow all around your body. Okay? So, in this case, one of these hormones that can affect your bone growth, again, so it's coming out from a different organ, but then that hormone that they dump into your blood flows eventually into your bone, affecting your bone growth. So one of them is human growth hormone called HGH. So this hormone is produced by the pituitary gland, which is a little tiny, I mean, it's super tiny. We're talking like that small. This tiny little nubbin, like smaller than a pea, that's stuck to the bottom of your brain, next to your hypothalamus. So this little pea-shaped bit attached to your brain, its job is to produce lots of hormones, and one of them is human growth hormone. When it's dumped into your blood and reaches your bone, it will induce growth in your periosteum and your epiphyseal plate, as in the area, your epiphyseal plate allows your bones to grow longer, and in the periosteum, which is the outer edges of your bone, if HGH is stimulated, it'll also make your bones grow wider. Okay. So HGH, among other things, also on top of growing your bones, increases the size of your organs, increases protein synthesis, such as the proteins needed to make your bones grow, and it increases calcium retention, again, the things that help pack on calcium to make your bones grow. All right? If you have too much HGH, though, this could be a problem. Now, the biggest cause for having too much HGH is having a tumor on the pituitary gland, which then promotes extra HGH. Now, if you're young, if you're under 25 when this happens, you get gigantism. So you get excessive growth on the outside of your bones. So your bones, yes, they grow bigger, wider, but they also grow a lot longer. So you get very, very tall, and your bones get very, very thick as well. And you can see that because the shape of the face really alters and changes in someone with gigantism, or what's called acromegaly. So acromegaly occurs in adults. So this is when you have a tumor on your pituitary gland, but your epiphyseal plates are no longer there, they're lines. So at this case, these people don't grow taller when they have a tumor, and instead, though, their bones do get a lot thicker and a lot wider. So their shape of their face especially also changes and gets denser and starts to poke out more in their face. So they get this changed shape of their face, but they don't necessarily get taller. But in both these people, because it increases the size of their organs, they're at a higher risk of strokes in their brain, especially because the increasing size of blood vessels can make them weaker. But in particular, the most scary part is your heart. When your heart gets enlarged, it can't do its job as well. Its size, it affects its ability for its size to be efficient, and in addition to that, it can change the shape and structure of vessels, which then weakens them, which increases the chance of having a heart attack or stroke. So, Andre the Giant, who is a fairly famous wrestler and actor, he was in Princess Bride. Some of you may be into that. What ended up happening for him is he was really famous, but he died fairly young because he had a heart attack because of his enlarged heart due to his condition. Okay, the last major factor we're going to go over and hormone we're going to go over is sex hormones. So sex hormones are the hormones produced by the sex organs, the testes and ovaries in people. So, if you have testes, you produce testosterone or androgens. Androgen is the main hormone, and then testosterone is a offshoot of the androgen hormone, meaning there's a bunch of androgens and testosterone is like the biggest one. Estrogen is produced by people with ovaries. Okay? Now, both of these sex hormones stimulate formation of bone. This is actually the biggest reason why puberty makes you grow taller, because puberty leads to higher production of sex hormones, which then makes you grow taller. However, and that you also shift your amount of sex hormones over your adolescent years. So actually you have this really big peak and then it kind of slows down, and that change is actually the trigger that causes your epiphyseal plate to develop into a line and then stop your growth or your bone elongation to grow taller. Another thing is testosterone. Typically, though estrogen and testosterone play a similar role in terms of bone development, testosterone is more effective in allowing your bone to develop and grow longer and grow dense and become more dense. So generally speaking, then, as a result, this accounts for why people who have testosterone are taller than those who have estrogen, okay, or females in general, for the majority. So this is why most males typically are taller than most females. And this goes for people with hormone treatments as well. So if you are trans, for instance, exposure to testosterone or exposure to estrogen will also create a similar effect, both as an adolescent in terms of effect on height, and we're going to learn later on estrogen and testosterone also affect bone density in your elder years. And I'm going to go over that in a later lecture, but basically, people who produce a lot more estrogen, generally speaking females, what happens is we're much more prone to having osteoporosis and weaker bones when we get older. That's why your grandma shrinks way quicker than your grandpa. All right, key takeaways. Outside of genetics, there are several lifetime factors that can affect how your bones develop into adulthood, and especially how long and how big they get. The minerals calcium and phosphorus are essential for the strength of bones. If you don't have enough of that, you're not going to create a lot of bone tissue in the first place. Vitamins, like vitamin D, are necessary for the absorption of calcium from food, and without that, you get rickets and soft bones. Vitamin C helps produce collagen, and vitamin A helps regulate the cells that are needed for bone development. Hormones also affect bone growth. In this case, HGH is really important for in terms of stimulating bone production, but too much HGH can result in bad side effects, not just growing very large bones, but also affecting organs and causing health problems. And sex hormones also play a major role in regulating how tall you get, and it also plays a role in regulating how long your growth spurts occur. All right, so that concludes the lesson. Go on and do any other work you've got for today. Bye.